Hi, and welcome to Periergy. In the last video on the SuperSolver, I showed you how first expression was working and how it was cleaning my expression. And you can see that we called him right over here, and then we said if the expression had any error, then just say, sorry, we couldn't solve the expression. And then we went into the main loop. Now, the first thing to do is find the right set of brackets to work on, and that is done by this function, find inner expression. That, as you can see, it takes the expression, which is the same one that main does take, and it returns the start of the opening bracket, the finish index of the closing bracket, and the inner expression, which is the set of brackets. Therefore, if we had something like this, it would just give me this brackets included. And you can see the code right over here. It's quite easy. Now, the first thing to do is find the closing bracket, and that is done by this function, find, which returns the first character right here. Now, this is the closing bracket that in here is just this one. And it looks for the character in the expression and it returns the index of that character. And then we have to say that if the closing bracket was not found, that means the expression is finished because no other sets of brackets were found. And as you can see in here, if start, which you can see that it just has the value -1, if start is indeed -1, it breaks from the main loop and the expression should end. But if that's not the case, that means that we have to find the corresponding opening bracket, and the corresponding opening bracket is found through a loop that takes an iterator, which is called index, and it goes all the way from closing bracket index -1, because we don't need to check if the closing bracket is an opening bracket because we know it's not, and it goes all the way to 0 going backwards. And if, of course, it looks for the opening bracket, if it finds it, well, it's going to break because otherwise it would just return the last opening bracket that it finds, but we need the first because we're looking for the corresponding opening bracket of this closing bracket. So the inner expression goes from all the way the opening bracket index, which you can see is included, and all the way to the closing bracket index, which is included by the +1. And it returns first the start, then the finish, and then the expression itself. And after we find the right set brackets, the next thing that we have to do is, after we check for this, is go into the other loop. Now, this loop is the one that makes sure that all the operations are actually evaluated before we go to the next set of brackets. The way to do that is first you have to look for the index of the operator that you need to do by finding the next operation to evaluate. The next operation to evaluate is found by this function, which takes the inner expression, so sets of brackets that we found before, and it returns the index of that operator. The code for that is in here, and you can see that it works really, really easily. Now we have our first for. This for takes an operator and the character that are the index of the current character in the expression. This is what enumerate function does. It takes the string and it says, all right, 0 and the first character go to index and char. So if the current character is a multiplication sign or a division sign, then return the index. Now, it really doesn't matter that it's a multiplication sign or a division sign, because as we have the index, we can always check what operation it is, and we probably need that in the future when we evaluate the operation. Thing that I haven't done yet, I haven't coded that, and that's why you can find this debug break. And the only thing that matters is that this for is actually before this one, because you need to look for multiplications and divisions and additions and subtractions afterwards. Therefore, if the compiler doesn't go into this if, that means that no multiplications or divisions were found, and you can look with the same code with just these differences if there are additions or subtractions. If that's not the case, that must mean that our operations are finished, because in this solver of the first grade expression, we only allow multiplications, divisions, addition, and subtractions. And therefore, we return -1 to signify to say that the operations are finished. And main does see that. So if the index operator is -1, it breaks from the main loop and it looks for the next set of brackets. And you can see the sprains are just for debug, so you can just ignore them. I'm just giving you the, how do I say this? This is just the progress that I have done in here. So if you have any suggestions, please leave them in the comments or write me on my email, me.periergy@gmail.com. But let's continue. Now, the first thing to do next is finding the numbers corresponding to the operation. So let's say we had a near expression of this. So this is our set of brackets. The first operation is going to be this multiplication, and the first number should be this one, which is a negative floating point number, and this one, which is a negative integer. To do that, we use this function, find numbers, that, as you can see, it takes the same inner expression, so the same set of brackets that we found before, and the index operator that we found from the next operation. And it returns the first number and the second number. Now, you can see in here that these numbers are actually strings, and we're going to turn them into floating point numbers or integers or whatever when we actually evaluate the operations. At least that's what I plan for now, because I don't think I should have them as floating point numbers right now, because it would probably be a pain. And the way to find our first number, so through characters, is have a for that does take an iterator that goes from the operator that we had all the way to the start of the expression backwards. And this is just a way to not write this every single time. And if the character is not a space character, this line just makes sure that we ignore spaces. And this lines actually make sure that if you find going backwards, like imagine we were here, no? We're going backwards and we're looking for the first character, which is not a space, not a number, not a floating point, not a floating point or a decimal point, whatever you want to call it, or a subtraction sign. We're looking for the next number, which is not ours, so we need to break right over here. And that's done by these lines right over here. You can check them for yourself, but if you don't want to, well, this just checks for if you find a subtraction sign, that means that you need to break and add that subtraction sign because we have a negative number. But if you don't, and you find a character that is not numeric, not a subtraction sign, and not a decimal point, that means that you need to break because that is not our number. If none of these things above were actually true, that means that we're still trying to retrieve our first number, so add that character. Now, at the end, as you might think, we're going to have our first number, our string, which is backwards, and that's why we have to, because we were going backwards, and that's why we have to turn the string, though we have to reverse it again. The second number is quite the same thing. The only difference is that instead of breaking at the first negative sign, we have to break at the second, because the first just signifies that we have a negative number. And you can see that we break right over here without including the second one. And that's done by these lines. So we have the same principle, the character just not to write the same thing over and over again, because this is too long, this is much longer than this one. And if you don't find a space character, well, just this ignores the spaces, but if you find a subtraction sign and it's not the one after the operator, and you find a character that is not numeric and it's not a decimal point, then just break. Or this just checks if we're still on the second number, or if we need to break because we're out of the second number. This just checks for this just adds character to the second number, and at the end, second number is not going to be backwards because we were going the right direction, and therefore it just returns first number and second number. Now, if you want to copy this code, this is free to you. You can use them whatever you want. Now I've prepared some debug code for you so that you can see all the functions in work. And if I run this code, you can see main functions with all the debug prints that we had. So you can see that this is the expression, and you found the right set of brackets, and you found the right operation, which is a multiplication. You can check this index counting from 0 all the way to here. This should be the 26th character counting from 0. And the first number had to be this one, and it is. And the second one had to be this one, and it is. Parse expression, instead, you can see that it cleans the expression if we have spaces which shouldn't be there, or too many, or just consecutive additions or subtraction signs. And you can see that it works. You can check for yourself that this does turn into a negative sign and this into a positive sign. Find inner expression just has to find the right set of brackets to work on, and I gave an example where the actual set of brackets is all the expression, and you can see that it did find all the expression, and this is the start, so this character, and this is the index of the last character. Find next operation to return this one, and it does 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is right. And find numbers should return from this operation -60.6 and -5. And you can see that it does. So I hope you've enjoyed this video. Please subscribe, please leave a like and a comment. It really does not help YouTube, but it really does help me because it would make me so happy. So hope you've enjoyed. Thank you.